Right. So you mentioned multicore. What is that? I need a refresher on that. And why does it increase supply, as you suggested?
Yeah, so there's a lot of new frontiers in
Hmm.
subsea cable. I think that's one of my favorite parts about subsea cable is that there's always something new to learn. And one
Hmm.
of those areas is in the mechanical engineering and the physics.
Right.
So to continue to expand the amount of capacity that we can fit through a subsea cable, changes essentially need to be made to the wet plant. In the
Right.
early 2000s, you could continue to upgrade these systems using different shore end technologies after they had entered service. So you could, change out a wave card or whatever the tech at the shore at the cable landing station, and use that to transmit more light through the same cable
Right.
and get more capacity out of it. Now, as the industry is approaching the Shannon limit and different like technological limitations, you can't just continue to do that unless we can get to the L band, right? Is this do a sorry, C plus L that's increasing the amount of wavelengths that you can send,
Right. Right.
different colors
So
of light
more
essentially down the cable.
efficient use of the spectrum, if you will, on the fiber.
Yes.
Right. Yeah. Hmm.
Um, so that is not something that's infinitely
Hmm.
improvable, right? So the cable itself, there's a lot of new ways that you can potentially get capacity out of it. And that's by putting more fiber pairs in, which again is limited by repeater technology, or even like chip capabilities, right?
Hmm.
Um, and then there's also, as I said, multi-core, much closer on the horizon than hollow core. But
Hmm.
anyway, so within a subsea cable, you have lots of optical fibers. And then
Right.
within those optical fibers, there's a tiny core. And that is what the light is actually sent down, and then it bounces
Hmm.
off the edges of the cladding that's around, again, that tiny hair sized optical fiber.
Wow.
Multicore is putting two or four or however many of those tiny cores in each optical fiber. And
Wow.
then, so you can,
Inside the human hair width fiber, you're putting
yes,
multiple places for the light to bounce and thereby increasing the potential capacity.
it's just incredible. Yeah.